Okay, so I was able to solve 5 problems, 1, 2, 3, 4, and 6th. So let's go to them. Problem A, obesity. So here we are given a formula for BMI, which is weight upon height square in the units kg per meter square. And then we have to tell if a person is obese or not, and that is true if a BMI is greater than equal to 25 kg per meter square. And so we are given the height and weight, but here we are given weight in kg and we are given height in centimeter, but in BMI unit is in meter, so we have to be careful of that. So like if you see in the example, this 180 is converted into 1.8 meters first, then it is divided. So if we see, just uh, if we are given h and w, so w divided by h square less than equal to 25 or greater than 25 for obese, let's say. Like we have to tell yes if obese, right? So yeah, this is the condition we have to follow. So generally, I personally avoid integer division, like avoid division as much as possible. So what I've done is w greater than 25 h square k square. But here the w is in kg and h square is in centimeter. So this we have to divide it with 100 square. So now it will be in meter. So 100 square I move here. So it will be w times 100 square greater than 25 times h square. We can simplify it more, but this is enough. And these are well within the constraints of a integer. Like this will not overflow. So if we see the solution, I take h and w as input. So I see like w times 100 square should be greater than equal to 25 times h square. Like 25 or more should be greater than equal to. So yeah, this is the condition I put. Accordingly, yes and no, we're printing. So that's the first one. The second one, we'll make purchases at n stores. So if we buy stuff worth AIN and we pay BIN, so we should get back the remaining value. So since it is guaranteed that AI is greater than equal to BI, so we should ideally get back BI minus AI. That is extra we are giving. So according to the store policy, like they do not, if SI is keep, then we will not receive this change. If it is take, we will receive the change. So we have to tell the amount of money we have lost. So the the idea for this is we iterate or we go through each store. We'll calculate this BI minus AI. If it is keep, then this we will not have this in a value. Then this is a loss we are having. If it is take, then we are received a change, so that is not a loss. So just we have to check for values that are keep, we are losing this money, so we will add BI minus AI to our answer. We need not maintain X and Y separately. This is more than enough. So yeah, like we maintain an answer which initializes with 0. Uh, then AI and BI take an input and S. If S is equal to keep, then we increase answer with B minus A and then print the answer. So yeah, that's problem B. Problem C, adjacent sums. Okay, so yeah, this is the easy version of the problem. I couldn't solve the hard version, but yeah, let's go through the easy one. So here we are given in two arrays, one of length n and one of length n minus 1. So it is like this. Let's say one of length n and one of length n minus 1. Let's say n is 5. And each value is between 0 to m minus 1. So in the easy version m is 2. So the values are from 0 to 1 only. 0 and 1 only. Uh, yeah, and then we can do this operation. So we increase 1 to increase any a of I with 1. And then we have to tell the minimum number of operations to make this true. So this is basically like this value should be the sum of these values mod m. So ai plus 1 is divided by m, so the remainder should be bi in that case. So in this case, since m is 2, so we can see in binary levels only. So increasing ai with 1 just means flipping it from 2 to 0 to 1 and so on. And then we have to tell if ai XOR ai plus 1 basically is equal to bi. So here is one observation. So if we have some values, let's say a, b, c, d, e. So the value we will have here is a XOR b, b XOR c, c XOR d, and d XOR e, like in the final state. So here the value can be either 0 or 1. So if let's say this was 0 and this was 1, let me use a different. Let's say this was 1 and this was 0, then this has to be 1. There's no doubt about it. And then if let's say this was 0, then we want XOR 0, so this one has to be 1. Then let's say this is 0, so this one also has to be 1. Let's say this is 1, so this has to be 0. So there is no ambiguity in that sense if b is fixed. So if we choose some value in a, let's say I decided this value in a, then all the values will be calculated accordingly. There's no ambiguity in that. Another solution we have is we flip all of them. This is also a valid solution of this, because like this is XOR, so this is like a XOR 1, XOR b XOR 1. So this XOR 1 will kind of cancel out each other, so we will get the same value. So these are the two cases we have in this easy version at least. So uh, we have only two fixed answers, and we can, so given a, we can find out which one is nearest to our case. So in this operation 1 1 1, we increase the second one, so we get 1 2 1. Here 2 doesn't matter because m is 2, so we can just set it as 0. So we can get 1 0 1, but 0 1 0 will also satisfy the answer, but so we will choose whichever takes the less number of operations. So yeah, so if we see my idea, I took input n m a b. Then if you notice that the first value and the last value, they only contribute to one of the values. So it was fine to start with this. So let's say initially I assume that I'm not going to change AI. This A is going to be fixed. In that case, I started with this. If AI is or AI plus 1 is not BI, then I increase the answer and I update AI plus 1. It will get a little messy, but I hope that's fine. So yeah, this is A, this is B. If A or B is not equal to this value, then I will not touch A. I will do B or 1, but this will be A only. I will do B or 1. So, so yeah, and that is my one solution. I don't update A, so I get answer accordingly. The number of answer is here is basically the number of values we have flipped from 0 to 1 or 1 to 0. So either we do that or we take the exact opposite. So instead of flipping these answer values, we flip the remaining n minus answer values. That is also an answer as we have seen. So the final answer will be the minimum of answer and n minus answer. I hope that makes sense. So yeah, that's problem C. Problem D. Okay, so here we are given 4 points and we have to check if we can have two concentric circles in which the first 2 points exist on the first circle and the next 2 points exist on the second circle. So, and concentric means like this, the center has to be the same of both of these circles. So like we can see this example only. So here P and Q are part of the smaller circle, R and S part of this bigger circle with the same center. So the observation here is that if let's say this was P and Q, okay, okay, that's fine. If let's say this was P and Q, then these 2 points, since they lie on a circle, they have to be at the same distance from the center, that is equal to the radius, right? So we take this line segment, we take the midpoint of it, and if we draw a perpendicular, okay, it's not very straight, but okay, I hope that makes sense. Can, yeah, so if we draw this perpendicular, so the center of the circle has to be existing on this line only. If it exists anywhere on this line, then we can uh, then that will have the same distance from P and Q. Similarly, for R and S, let's say this is R and S. If this will be the line segment and midpoint, we cut the perpendicular. Yeah, almost a perpendicular, but it's fine. So yeah, we cut this perpendicular and this intersecting point. This will be the center of a circle, because here from here we can draw one circle that is like uh, that passes through both P and Q, and we can have another circle that passes through R and S. Like I'm not drawing it clearly, but yeah, that is the idea. The distance of this point from P and Q is the same, and the distance to R and S is the same. So yeah, we just have to tell if these two line segments have a common intersection point. So yeah, I've done some maths here. If we see this, my initial observation was little incorrect, but yeah. So given given the two segments, given the 2 points, we find this line that can be that has a center. So yeah, first we find a midpoint x prime y prime, which is the midpoint. The slope of this line is y2 minus y1 by x2 minus x1. So the slope of the perpendicular is going to be negative of the inverse of this. This is like a known fact. And then I put this in equation of a line y minus y1 is equal to mx minus x1, and then I find the values for ax plus by plus c equal to 0. I find a line segment equation at that form, and that's what I put here. So I have this get line, and these three values are the values which I have derived just now. Yeah. So I have two line segments, two lines now, and then I have to check if they're intersecting or not. And like this, uh, if I can find it, yeah, this is like the condition for intersection. If a1 by a2 is not equal to b1 by 2, then there's one unique solution. If all the ratios are same, there are infinite solution. Basically, it is the same line only. And if a1 by a2 is equal to b1 by b2 is not equal to c1 by c2, then there's no solution. They're parallel lines. So in this case, the answer is no. This one edge case in this that I've handled, if both a1 and a2 are 0, like if both lines are parallel to x-axis or both are parallel to y-axis, then these equation I cannot do 0 by 0. That would be bad. But yeah, I think that would have also worked, but maybe I didn't need that. Mm, maybe it could have worked. I didn't need to handle it, but anyway, I did the x and y axis, and then this formula. As I said, instead of doing division, integer division, I prefer checking the multiplication. And one more thing here, the size, if we see the constraints, it is still 10 power 9. And if we see the formula, it has this y2 square and y1 square elements. So the maximum value of this ABC, if these can be till 10 power 18. And then I am multiplying two of these. So this can even exceed long. So I have taken a 120-bit integer to solve this problem. Like I'm not sure if we can do it without it, but it was simple enough. So yeah, that's problem D. Problem E I couldn't solve. like my main idea was, as I mentioned before, this idea is still the same. Like if we see these values, so this is like the relation for these four values and the five values. So if we can, I can choose literally any random element. Let's say I choose this one, and choose some x here. If I choose some x here, and let's say this was z, so this is going to be z minus x and modulo m. Everything is modulo m, so z minus x. So if I add it, I get z. And here this values are also fixed. This can be y, so y minus x is here. And then this we found. Based on this, we can find this and like everything else. But the challenge is to find this x, which give us the minimum number of operations. So as I said, there are finite values of the array A that will give us the that will satisfy this condition. But there are m combinations. Like I can choose this value anywhere from 0 to m minus 1, and accordingly I'll get all other values. But and then I can see which of them has the minimum number of operations. But m is 10 power 9, so an order of n into m solution definitely doesn't work. So that is my idea of a problem E. I couldn't optimize it further. Let's go to problem F. Okay, so here we are given two arrays and we are giving q queries in which we are asked to either update one of AI or one of BI. Then we have, after each query we have to tell this, solve this problem basically. So the problem statement says, like, let's ignore the updates for now. The problem statement says we need to send n emails, and for each j, it takes aj minutes to type the mail and bj minutes to receive the reply. So the total time is like aj plus bj something. But and we can only type one mail at a time. So while waiting for another mail, we can type it. That's fine. And we have to tell the minimum possible time at which we receive all of the emails, the replies. So the way if we just solve this problem, so the first observation I had is we should sort the mails based on the largest bj. So if this is like a1 b1 a2 b2, in the order that we will write mails, an, okay, one index is fine for now, bn, so on. If this is the order we are processing in, then b1 should be greater than b2 and so on, like it's in descending order. So I'm proving it is a little tricky, but observation wise, if you see, like you want to utilize your waiting time as much as possible, right? As you're waiting for other mails, you uh, want to write mails. You don't want to spend time waiting for mails and doing nothing. So if this is the last one you do, then you have to wait proper b1 time, which is a waste, right? Another observation is, if you process the mails in this time, the time is going to be max for all I prefix of AI plus BI. So it's going to be like A1 plus B1, A1 plus A2 plus B2, and so on. So like this is very easy to observe. We write for the ith mail, the time take us to write the ith mail is summation of AI from 0 to I, because we will write the first mail, then the second mail, then the third mail, and then we'll write the ith mail. And then we have to wait BI duration for its reply. So this is the time for the first one, the second one, and so on. And the maximum of these is going to be our answer, the minimum possible time. So to minimize this time, we chose this order basically. Okay. And okay, so this is the main idea. If we did not have updates, then this is how we are going to do it. But now we have updates, so how to do it? So updating AI is pretty easy. Like there's a standard problem called prefix sum queries. If you have done CSES, let me just show. So this is like the problem. We tell the maximum prefix sum in the range. Here we have here we have to tell the maximum prefix sum plus BI. So it's a very similar problem. So updating AI was not a challenge, but updating BI is a challenge because that will change our order of operation. Like the mailing order, the order in which we write the mail, that will is going to change. So that is a challenge. So how I tackled it is, uh, first of all, I've not done it in an online fashion. Like I did not process queries one by one, in the sense that I stored all the queries. I stored all the BI values I am going to get. So let's say I start with n, I get these n values, and then in queries also, like let's say these were the BI values, uh, and then we get in the query we update this value here. Uh, okay, no, we update BI, right? So yeah, so 467 and then 7 and then 1. So these are the all the BA values I am going to get in this problem for the given input. Then I have done is like I've done a coordinate compression to for all the BI in the sorted manner. So in this, let's say it was 4, 6, 7, 7 and 1. So 4, 6, 7, 7 and 1. So if we coordinate compress it, we are going to get something like 1, 4, 6, 7. These are going to be the BI values, right? Another observation from this part is that if we have some like A1, A2, let's say A1, A2, B1, B2, and B1 is equal to B2, then I can kind of convert it into a single entry of A1 plus A2 with B1. I mean, this is why this is true, because let's say we will first write this one. This will take A1 plus B1 time for response. Then I'll let this one. This will give A1 plus A2 plus B2 response time. So the smaller one is never going to matter. This is always going to be the dominating factor. So I can just ignore this at all. And I can add up these values for the same B and just convert it into a single entry. How this will help is, now I will maintain these B values, and at that point I will maintain all the sum of AI values I have for that BI. I hope that is making sense. Uh, I can show it for this example. I have 1467, or let me just write it properly. 1467. So initially I have 4 here. This is going to be the A, this is B, and technically summation of A. So this is going to be 4, 6, 7 and 0 initially. So this is 0, so we will not consider this B in our answer. Now for a little implementation detail, I actually for coordinate compression I sorted this in ascending order, but here we wanted B in descending order. So instead of prefix sum, I have taken the suffix sum. So the time is going to be 7 plus 7. Here it is going to be 7 plus 6 plus 6. Here 7 plus 6 plus 4 plus 4. And the time for this is 0. We don't consider this. So this is 14, 19, 21. I hope I'm correct. This is 90. Yeah. So this is going to be the time for initially, like t0. And then our first update comes, we update, sorry, sorry about that. We will update a of I to x. So we will update a of 2 to 1. So like it was like 467, 467. A of 2 is this. So we will update this to 1. So this is updated to 1. Right. And then we will check again 7 plus 7, 7 plus 1 plus 6, 7 plus 1 plus 4 plus 6, 14, 14, 18. Wait, what? Oh, sorry, this is 4. 7 plus 1 plus 4 plus 4. And this is 16. Yeah, so this is the decider. So 6 T1 and this is 0. So 16 is our answer here. And I can go on like this. Here now this one is a crucial one. 237. Okay, so just this is just updating 7 to 7. So I'm not showing it. The answer doesn't change. This one 231. So now we will update this 7 to 1. So now what we will do is I will change this 7 to 0. I will subtract 7. I will subtract this AI from here to make it 0. And since this is 0, this is also not going to contribute anything. And now for the new BI 1, I will add this 7 here. I hope that is making sense. For this B, now we got a new A. And for older one, we updated it. So now if we check T3, technically T2 was the same. So this is going to be 0. And this is going to be 1 plus 6. 1 plus 4 plus 4. 1 plus 4 plus 7 plus 1. So this is 7, 9, 13. And 13 is our answer. So that's my most broadly my idea. To implement it as similar to the prefix sum queries problem we have seen, I have this is solved using a segment tree. So if we check the solution for f, so this is my segment tree idea. In one segment tree node, I will store the sum of all the elements in that range. The maximum suffix sum I am getting, that such that the suffix sum plus b is the larger one. Mind you, this is not the maximum suffix sum of the range. This because that will be entire range. We are not dealing with negatives here. This is suffix sum with which uh, in which we if we consider b, then it is the largest one. So yeah, and if we see the merge idea. So like if we have the left part and the right part of segment tree. So yeah, this is A, this is B. So here we have sum 1, suffix 1 and B1. Here we have sum 2, suffix 2 and B2. So the suffix part for A is going to be sum of 2. Like if this was the suffix for A, now the suffix is going to be sum 2 plus suffix 1. So suffix 1 plus sum 2 plus B1. If that is greater than suffix 2 plus B2, and this is the right portion, the largest suffix 2 we get. If so, this is like the suffix sum if we consider the left part, and this is a suffix sum we get the right part, suffix sum plus b, and accordingly we choose the values for which maximum suffix to take and which b to take as well. So, and a little implementation detail here, I mentioned that since this is 0, this 7 will not matter. So to measure that, here I have not done the handling, but here I have set this b as 0. So b is either going to be this value or it is going to be 0 accordingly. So when we go to the implementation, I take the input, I find all the values of b, I take the input of queries as well, and then this is like standard coordinate compression idea. sort and delete duplicates. So I get this 1467. Now I create a segment tree. So now to update the segment tree, I find the index at which matches this value y. So x and y are iterating over a and b basically. So I check for this compressed value, the position where we match this b, where like the index basically. Let's say 6 was there, so we will return 2, 0, 1, 2, 3 here basically. And at 2 index in the segment tree, I am going to update it with the I'm going to add x, which is basically ai at this point. And as I mentioned that as an implementation detail, this will be either 0 or it should be either y, the current b value in the node. And then we process the queries. And so yeah, now in processing of queries, if we are updating ai, then we just need to add the value. We need to update the value. So if at index I we are going to update ai with x, so I just take the sum. I do sum minus ai plus x. I just remove, like basically removing ai and adding x, because we are not changing b or y basically. We are not changing b, so it doesn't matter. So a little assertion to confirm that. And at which position we will update, we already found that using b. Okay, I hope that makes sense. Now if you're updating b, then as I said, we will update the current position for bi. I have not updated bi yet, so this is the current position having the nodes for bi. There I'm going to remove ai from the answer, and I'm going to set b accordingly if it is 0 or b, as I mentioned. Now I update bi is equal to x, and then I again update the value. I hope that is making sense. It's might be a little tricky to understand. Took me some time to actually come up with the idea, but yeah. So after this update is done for either a or b, we query over the entire range, and we find the largest value. This q dot 1 is the suffix and q dot 2 is the b, so their sum is going to be the value, and as we seen, we choose the largest one over the entire range. I hope that makes sense. So yeah, that's all from my side. Thanks for watching. Bye.